Good morning or afternoon, depending on what time you're watching this video. Our learning target today is to be able to add and subtract rational expressions. So we're going to get started right away since we have quite a few problems I want to get through. If you recall, in problem number 5, we're going to start by going ahead and trying to make a common denominator. So if you recall, when we make a common denominator, we're looking for the least common multiple, in which in order to do that, we'll have to take out the factors and decide and make sure that every single denominator has the exact same factors. So I've got in the first fraction in problem number 5, I have a factor of x. In the second fraction, I have a factor of 6 and a factor of x, so I can rewrite this as 6 times x if I wanted. And in the third fraction, I have a factor of 2 and x. So when I think about the least common multiple for all of these fractions, they all have a factor of x in them, right? So the least common multiple, or the lowest common denominator, which is what we're trying to make, is going to have a factor of x in it. And then if I look at 6 and 2, 6 can be broken down as a factor of 2 and 3. And so what all of my fractions will need is a factor of 2, 3, and x. So the least common multiple is going to be comprised of the factors x, 2, and 3. And so when I break it down like that, I think about this and say, okay, so this is what I want all of my denominators to look like. So the first denominator needs both a factor of 2 and 3. And because I'm not going to write out 2 times 3, I can think of that as just multiplying that denominator by 6. Now, if I multiply the denominator by 6, in order to make that common denominator, I also have to multiply the numerator by 6. And one thing you'll notice is that because the numerator has an expression in it, I'm wrapping that expression, 3x plus 4, in parentheses, so that I remember that I need to, when I multiply this out, I need to actually distribute that 6 all the way through, okay? And then in the last fraction, I need a factor of just 3, so I'm going to multiply this last fraction just by 3. And if I do that in the denominator, then I'm going to also do that in the numerator. So I'm going to rewrite this and make it a little bit neater. So the first fraction is the quantity 6 times 3x plus 4 over 6x. The second fraction is now minus, we didn't change anything in that one, so that's 5 over 6x. And the last fraction is now 27 over 6x. And so now all of my fractions have the same denominator of 6x. And then at this point, I can then go ahead and start simplifying those numerators, right? So I can rewrite this entire expression all over 6x, and I can simplify it. So the expression that I have is 6 times 3x plus 4 minus 5 plus 27. And if I simplify that, I get 18x plus 24 minus 5 plus 27 all over 6x. I'm going to keep simplifying that. So 24 minus 5 is 19. Ooh, let's actually do this. Negative 5 and 27 is 22, and 22 plus 24 is 46. So this is 18x plus 46 all over 6x. And the last little bit of this is for me to go ahead and check and see, is there anything I can simplify out among all of these terms, right? So 18, 46, and 6 can all divide by 2. So since I can take out a factor of 2 now, this is going to be 9x plus 23 over 3x. And that's my final answer. Now, one thing I didn't do when I started, I'm gonna make sure I start this way in the beginning on the next problem. One thing I didn't do is identify any restrictions that I might have. And so in this simplified version, I know that 3x cannot equal 0 because that would mean I'm dividing by 0. And so ultimately, I have the restriction that x cannot equal 0. Okay, so let's just kind of review again in the next problem our steps to simplifying, to adding or subtracting two rational expressions, right? So the first thing that we did was we made a common denominator. Okay, so let's do that for problem number 7. So in problem number 7, I want to make a common denominator. Now, this one's a little bit different than the first one because I have an expression on the left-hand fraction. Okay, and that whole expression is a factor all in itself together, right? So the left-hand fraction has a factor of x minus 1 in the denominator. The right-hand fraction has a factor of 4 in the denominator. So when I think about the least common multiple, I need to do a factor of 4 and a factor of x minus 1. So my entire denominator needs to have both a factor of 4 and a factor of x minus 1. Okay, so let's go ahead and do that for both these fractions. So the left fraction needs a factor of 4. So I'm going to multiply by 4 in both the numerator and denominator. The right fraction needs a factor of x minus 1. So I'm going to multiply by x minus 1 in both the numerator and denominator. Okay, so now I can make one fraction with the numerators combined and the common denominator underneath. Right? So this is what I have in the denominator. The common denominator is 4 times x minus 1. In the numerator, I have the expression 4 times 6, right? So that's 24 minus 5x multiplied by x minus 1. Okay, now I'm going to go ahead and simplify the numerator and identify my restrictions. From the denominator. So for my numerator, I have the expression, it should be 24 minus 5x squared. If I distribute a negative 5x to a negative 1, that's going to be a positive 5x. And then that's all over 4 times the quantity x minus 1. Restrictions from this denominator, right? I'm asking myself what would make that denominator 0. The 4 I don't have to worry about because that can't equal 0 regardless. So it's really the fact that x minus 1 can't equal 0. So x cannot be equal to 1. If I add 1 to both sides, I'm going to get x can't be 1. And so my final answer, now I'm going to rewrite this a little bit. I don't really like the x squared as the second term. So I'm going to make this negative 5x squared plus 5x plus 24. And then I'm not going to multiply out the denominator at all because I know this expression actually isn't going to simplify. So because it's not going to simplify, I leave my final answer as is. And that's it. Okay, let's try a little bit more of a more complicated one where we got some common factors, not just a constant, but an expression for the factor in both the left and right denominators. Okay, so for this one, it's very common for people to think, okay, they both have an x, check. And so this fraction has a positive 3, this one has a negative 3. So let's just multiply this fraction by negative 1. The issue with that is the minute you do that, you actually get negative x minus 3. And so that's still not the same denominator. So what we need to do is we need to think about the fact that this expression is not the same as this expression. And so those are two different factors, right? If I think about x as if x were 2, this denominator would be 5 and this denominator would be negative 1. So they wouldn't be the same at all. So they're both a unique factor. So when I think about making that least common multiple for my factor, where did that go? Hello. All over the place. There we go. Okay, when I think about making the least common multiple is actually going to be made up of me doing x plus 3 and x minus 3. Those are two completely unique factors. Okay, so I'm going to focus on this first fraction. That first fraction needs the entire factor, x minus 3. It has the x plus 3, right? But it needs x minus 3. So I'm going to multiply this first fraction by the quantity x minus 3. And you'll notice that every time I multiply an expression by a constant, so an expression being x minus 3, a constant being 1, you'll notice that I always put it behind the constant. I do that because I like to distribute from the front, not from the back. Okay, and then I am minusing, now this denominator needs a factor of x plus 3. So I'm minusing 1 times x plus 3. Whoops. Okay, so I made that least common multiple. Okay, cool. So I made a common denominator. So now let's go ahead and rewrite this expression with one denominator. And that single denominator is the expression x minus 3 times x plus 3. And then the numerators are 1 times x minus 3. And I'm subtracting 1 times x plus 3 from that. So I made the common denominator. And then I combine the numerator. And now I'm going to simplify the numerator and identify restrictions. This could be two different steps. I kind of put them in one. Okay, so let's simplify that numerator. That's x minus 3 minus x minus 3, right? Distributing that negative 1 to both the x and the 3. Okay, over still the x minus 3 and the x plus 3 in the denominator. And then when I simplify that completely, x minus x, those are gone. So I just get negative 6 over x minus 3 times x plus 3. I don't have any common factors between the numerator and denominator, so my restrictions come from this denominator here. X minus 3 can't equal 0, and the expression x plus 3 can't equal 0. So that means x can't equal 3, and x can't equal negative 3. Final answer is the expression negative 6 over x minus 3 times x plus 3. We got a couple more minutes here, so let's do a couple more problems just to make sure we're getting the hang of it. Ooh, I like this one. I like this one a lot. So this one, I've got x squared minus 1 and x minus 1. And I look at this and I say, well, those aren't exactly the same, right? And I'm looking for common factors. So if you remember in the very first problem that we did, when we looked for the least common denominator, or the least common multiple for the denominator, right? We were looking at factors. We kind of pulled that out. We didn't just multiply the 6 by the 2 and make it 12. We looked at 6 and said 6 can break down into 2 times 3 times x, right? So we want to think about all of our denominators in their completely factored form. Okay, so for this particular example, I'm going to have to start with a different step before I can make the common denominator. So there's like a making a common denominator step. So the first step is making a common denominator. We have a pre-step here. We need to factor the denominators so that we know what the common denominator is actually going to be, right? So if I look at x squared minus 1, I see a difference of 2 squares in that. And so that's going to factor into the quantity x plus 1 times x minus 1. And now, when I try to make my common denominator, now I don't have to just multiply x squared minus 1 by x minus 1 because I notice that this factor already has x minus 1, right? So the least common denominator, or the least common multiple, is actually going to be the quantity x plus 1 times x minus 1. So it's actually going to be that x squared minus 1. So the right fraction needs a factor of x plus 1. Now I'm going to wrap that in parentheses. And this x minus 3, I'm going to also wrap in parentheses because I'm multiplying the entire numerator by the quantity x plus 1. And so I want to make sure that I don't forget to multiply that expression out and end up doing a binomial by a binomial. So then I have my common denominator. So now I can go ahead and write this, right? So we're going to go ahead and write this as a single fraction. Now that I have that common denominator, right? So it's all over x plus 1 times x minus 1. That might have been too big of a fraction bar. And I have x minus the quantity x minus 3 times x plus 1. So I'm going to do a little side work for this because I don't know exactly what x minus 3 times x plus 1 is, right? So I need to multiply that out, do a little side work over here. X minus 3 times x plus 1, my bad, is going to be x squared plus x minus 3x minus 3, which is x squared minus 2x minus 3. And now remember, I'm subtracting that whole quantity. So I'm going to go ahead and make sure that I do x minus that whole quantity. X squared, what was it? Minus 2x minus 3. all over the x plus 1 times x minus 1. We've got some restrictions, so we'll identify those before we move any further. Restrictions, x plus 1 can't equal 0, and x minus 1 can't equal 0. I don't know why I wrote 11. There's no 11 in this problem. Okay, x can't equal negative 1, x can't equal 1. And let's go ahead and simplify that numerator a little bit more. It's x squared minus x plus 2, or sorry, x squared minus x squared plus 2x plus 3 over x plus 1 times x minus 1. And then one more simplification, combining these like terms here. These two can combine. And so I end up getting negative x squared plus 3x plus 3. And that can't factor any further. That's going to be as simplified as it gets. So I'm done there. We're just rolling right through these problems. Okay, let's try one more. We got a few minutes before we hit that 20-minute mark. I don't want this video to be any longer than 20 minutes. Let's see, what else? Let's do problem 5. Yeah, this one's great. I really like this one because I think it poses a little bit more of a challenge, right? Because we've got both denominators are factorable, right? So we're going to start with that precept, factor the denominators. Okay, so we're going to factor x squared minus 16. That's a difference of 2 squares. It's going to be x plus 4 times x minus 4. We're going to factor x squared plus 7x plus 12. That's a lead coefficient of 1 problem. So I'm looking for numbers that multiply to 12 and add to 7. That's 4 and 3. So I'll do x plus 4 times x plus 3. And so now I can go ahead and make my common denominator. Looks like both of these fractions have a factor of x plus 4. Okay, the left fraction that has the blue denominator has a factor of x minus 4, so we're going to need that. And then the right denominator has a factor of x plus 3, so we're going to need that. So my least common denominator is going to be x plus 4 times x minus 3 times x plus 3. And so I look at this left-hand fraction, and the denominator has the x plus 4, it has the x minus 4. It needs the factor of x minus 3. So I'm going to multiply the left-hand fraction by a factor of x minus 3. The right side, the right denominator, has the x plus 4 and the x plus 3, but it's missing the x minus 4. So I'm going to multiply the right side by x minus 4. Okay, now I've got that big, long denominator. It's x minus 3, it's x plus 4, it's x minus 4. And I'm going to put those numerators together, right? So it's going to be x minus 3 times x plus 1 minus x multiplied by x minus 4. Okay, and again, I need to do a little side work because this is a binomial times a binomial, and I can't just distribute that super easily. So on the side here, I'm going to multiply out. Maybe I'll go underneath, actually. I'm going to multiply out the x minus 3 times x plus 1. That gives me x squared minus 3x plus x minus 3. So I get x squared minus 2x minus 3. So this is going to be x squared minus 2x minus 3. Distributing that negative x here makes negative x squared plus 4x. And that's all over x minus 3 times x plus 4 times x minus 4. Before I simplify any further, I'm going to identify those restrictions right away. Right? So I'm going to identify, hey, I've got some restrictions here. I know x minus 3 can't equal 0, right? All those factors in the denominator. X plus 4 can't equal 0, and x minus 4 can't equal 0. So that means x can't equal 3, x can't equal negative 4, and x can't equal 4. And then we simplify up this numerator a little bit. X squareds are gone. Negative 2x and 4x makes 2x. So this is 2x minus 3 in the numerator. And I end up with 2x minus 3 over x minus 3 times x plus 4 times x minus 4. Now, sometimes people try to multiply out the denominator. You probably noticed throughout this entire set of problems, I never did that because there's really no need to. So multiplying out the denominator doesn't get you any further in the problem. And so we can leave our final answer just like this. All right, we went just over the 20-minute mark, but hopefully that gave you a good start and you'll be able to do work on the rest of your problems. All right, have some fun.